Hi, everyone, and welcome. We're going to get started. Thank you for joining us today for our second webinar of 2025. My name is Brandon Searle, and as usual, I'm going to be moderating our webinars today. So just a quick overview. I'm going to do an intro of the Offsite Construction Research Center as well as Building Transformations, who has partnered with us on this. I'm then going to hand it over to Michelle from BDP Quadrangle. She'll then do a presentation on everything that they're doing as it relates to offsite construction and highlighting some projects happening in the GTA. We'll then host a Q&A and discussion and wrap up. As always, you can submit your questions at any time using the Q&A feature in the control bar. Some folks have a tendency to write it in the chat, which is fine. My colleague Roshni will bring it over to the Q&A. If you have difficulty hearing, check your speaker settings in the audio settings, and if your issues persist, just reach out in the chat and Roshni or myself can give you a hand. If you have any other problems, just tell us in the Q&A or by chat. As always, our sessions are being recorded and made available both on our Research Center website and on the Building Transformations website. We also do a blog kind of summarizing the presentation and encourage folks to check that out on our website as well. So a bit about UMB. UMB is located in Fredericton, New Brunswick, and was founded in 1785. It is home to Canada's first engineering, forestry, and computer science programs, with engineering courses first being offered in 1854. Since then, UMB has grown significantly with campuses in both Fredericton and St. John, New Brunswick, over 25 leading research institutes and centers, and over 25 world-class research chairs. In addition to the research success, UMB has been very successful in helping foster a startup community on the East Coast, has seen over 100 startup companies come out of the Fredericton campus since 2013, and we're even named Canada's most entrepreneurial university by Startup Canada about a decade ago. So about a bit about the Research Center. We were started in 2018 with through a partnership with Osco Construction Group. And then over the 3 or 4 years, we tried to understand, okay, what exactly can the Research Center do for the construction industry? And then we created a strategic plan in collaboration with our executive board. We focus on industry relevance, collaboration, excellence, and integrity as our values. And we have kind of 3 core research services, focus on process and productivity improvement, digital technology implementation, and lab testing services. Beyond that, and I guess kind of overlapping with our research services are areas of expertise. So again, our process and productivity improvement, mostly led by our chair, Dr. Zen Lei, focuses on productivity, safety, and quality improvements using simulation, optimization, different digital technologies, including scan to BIM, focused on optimized factory layout, as well as DFMA. We also have digital tech implementation. This is focused on BIM and VDC, or new technologies coming into the sector that support the moving activities from on-site to off-site. We're growing our structures and building enclosure testing lab, and that's in collaboration with Dr. Alan Lloyd here at UMB. We focus on panelized and volumetric modular connections, MEP connections, construction material testing, and recently launched our building enclosure testing lab off campus. And then finally, the benchmarking and innovation in construction. We're seeing a lot more activity in this area where government and the industry is looking at understanding the maturity of our sector to respond to housing crisis, shortage in healthcare facilities, schools, etc. And so understanding, what are the gaps, what training is required, what policy changes are needed, and how do standards and procurement strategies need to change. And so we do some research in that area as well. Next, we have our partner Building Transformations. So for folks who aren't familiar with Building Transformations, Building Transformations fosters industry innovation by providing programs which help our members push the industry forward. It has many programs to serve members, including both in-person and online events, certification program for professionals, organizations and educational institutions, think tanks for different segments of the construction and building industry, the annual awards program, and the annual Innovation Spotlight publication. Here's just a snapshot of the members. So the organization's been around for just over 15 years now, operates across Canada and the US, and has over 2,000 members. If you're interested in a membership, you can check out the link there, the website. And I just wanted to mention that the Innovation Spotlight is in its 10th year, and there will be a publication launch coming up next month. The event schedule for 2025 includes the AGM, which actually just happened. So if you are a member interested in learning more about the organization, you can check out that recording on their website. They have the 10th Innovation Spotlight publication launch happening at Olympic Stadiums, or they're doing a publication launch, sorry, in Montreal, Quebec, in addition to a tour of the Olympic Stadium site walk. We'll then be hosting an event in Austin, Texas, the Future of Design and Construction, April 2nd to 3rd, 2025. And then in Toronto this October, we are combining our AGM Industry Summit and the Innovation Spotlight Awards into a 3-day conference happening in October, and the dates will be announced within the next couple weeks. We just want to thank the mission partners at Building Transformations. You can see here PCL being the largest partner, as well as Bentley, and then you can see a list of organizations that have been involved in building transformations for a long time. And then finally, I want to thank our core sponsors, the Government of Canada, specifically through ACOA and OSCO Construction Group. And then our marketing partners are all listed here, and they help us promote our conferences and webinars. So I'm going to hand it over to Michelle. Michelle's the Innovation Director at BDP Quadrangle, and she'll be presenting on the applications of offsite construction and high-rise residential. Michelle, I'll invite you to turn on your mic and video and share your screen.
Okay, perfect. Everything working? You can hear me?
Yep.
All right. So good afternoon. As Brandon talked about, so I'm going to be sharing some of our experience in offsite construction, really with a focus on multi-unit residential sector. It says high-rise, but it's sort of high-rise and I-rise, which kind of intermediate rise. So if you attended the presentation by CAST Consultancy back in October in this webinar series, you'll see that they spoke about various market sectors requiring a different approach to offsite construction. And private housing is one that has really sort of a lower opportunity to influence demand and drive scale, given the fact that it's quite bespoke in nature. Each project is for a different audience. In the end, it's going to be the market that drives the adoption of offsite construction methodologies in this sort of private sector of residential. And really, that's going to take a lot of collaboration with industry on the benefits of offsite construction for this to kind of move ahead. So I'll start by telling you a little bit about BDP Quadrangle and who we are, and then I'm going to move into why we're shifting to collaborate around OSC, and then share a few case studies of our recent experience and sort of mix that in with a few other projects that are going on at the moment. So first of all, who are we? We're a multidisciplinary firm. We're about 1,300 people across 19 studios, and BDP Quadrangle is the North American head office of BDP. We have about 220 people, mostly architects, and we have a strong focus on the multi-unit residential sector. Here you can see some of our client base, so you'll note that we work across many brands, across many sectors, spanning both private and public sector, which gives us sort of a unique view of OSC across sectors. And I'll show you a few of our most notable projects where we have integrated MMC, just so you can get a sense of what we do. So here we've got the well, which is actually where I work. You can see the roof, the roof spine at the well, which is all digitally fabricated and brought to site. You've got Gap House, which was a contemporary housing project where they use standardized elements in factory production to allow these homes to be produced in volume off-site to reduce disruption in neighborhoods. 80 Atlantic, which is actually one of my projects, and I'll get into a little bit more about this later. It was the first mass timber office building to be built in a century in Ontario. Everton FC, so a new 50,000 seat stadium, which used a combination of generative design processes and hybrid OSC methods for prefabrication, prefabricated wall panels and framing systems. And then in the UK, BDP led AstraZeneca's new global R&D headquarters on the Cambridge Biomedical campus. So this was built with prefabricated sawtooth roof sections, and leave that one. Boxpart is an event space with food and beverage providers. So this was modified shipping containers, and this was sort of put in as a prototype to install as a way to quickly activate an up-and-coming site. This has been repeated in multiple sites in Shoreditch, Wembley, and Liverpool, and it also has potential in other contexts, which we're curious to explore. Alderhay Children's Hospital, which used precast concrete structure and wall systems and modular cladding, washroom pods, M&E modules. So the hospital sector in the UK has been one of the sectors where policy has really driven innovation and many lessons learned have been garnered. Now, as I mentioned, here in Toronto, we've got a huge portfolio of private sector multi-unit residential, spanning from mid-rise to high-rise, and with such a large and diverse client base and the knowledge of our UK counterparts, we've had an interesting platform from which to launch our efforts. So first of all, why OSC? In terms of trends, we know that we have parallel drivers occurring at once: an affordability crisis, a housing crisis, climate crisis. And then meanwhile, we have both a skills gap and a productivity problem in our workforce. And in parallel to this, we have a technology revolution underway that we can use to harness and shift how we make buildings from design through execution, where we can track supply chains, plan a building, using principles of circular economy and design with considerations for both how we assemble the building and then how we disassemble it at end of life. And so given, we have a Canadian issue of building lots of homes, and here in Ontario, we know we need to build 1.5 million homes by 2031, and we need to more than double the number of homes that we're building annually. We have to do this all while reducing our carbon footprint and make this housing more affordable and transform our industry all at once. So it's no small feat what we have to do. So here at BDP Quadrangle, our goal is really to support our clients' challenge to build housing that's affordable and bring their product to market quickly and systematically. And the purpose here is to really drive their competitive advantage using OSC. So I'm one of the co-directors of BDP Lab, which is a place where we conduct research across the practice. We collaborate with industry and academia, people like the University of New Brunswick, and we put this piece on DFMA, or design for manufacture and assembly, together as a snapshot of industry and ourselves in the context of this. So it's sort of an internal document, but it got us all talking. And one of the things that came up is that this field is extremely acronym heavy. So I like to start by defining the ones that I'm going to be using. So DFMA is really that overriding philosophy for all the means of delivering the offsite approach. So simplifying the part count, designing for automation, maximizing design reuse. You got the list right there. And then in the UK, they tend to use the term MMC, or modern methods of construction. This tends to be the one that I find most useful because it's a way of thinking about multiple non-traditional technical solutions to accelerate construction. So some of those methods are used on-site and some of them are on-site. And that's actually kind of how I've structured my presentation. Then you've got platform-based design, which is really something we're seeing evolve, where construction is thought about more like the automotive industry. So product delivery rather than project delivery. So it's a very different way of thinking. And you're seeing some companies come out that maybe weren't even in the manufacturing side before. So an interesting kind of emergence from outside industry. And then, of course, offsite manufacturing, offsite construction, industrialized construction, all likely be using these terms interchangeably, but I liked kind of this one piece that looks at all that taxonomy together. So as I mentioned, I find this MMC category is really useful as a way of organizing my thinking in this space, with the first 5 categories representing the offsite and near-site pre-manufacturing, and then the last two being about speeding things up, speeding up that efficiency of traditional processes on site through robotics and other means. And what I'm finding in high rise is we're really looking at those first five and really, some of those more than others. So you'll see some examples that I put out there. I'm going to give you an overview of multi-unit residential projects. Some of them are by us, where I'll go into a little deeper detail. So I'm going to go in deep on 3 projects, and the other ones I'm just going to touch on so that we can get an overview of what's happening. Some of the precedents started in another sector, and then I'm going to demonstrate how they've led to innovations in the multi-unit residential space. And the other thing I'll say is I'm definitely giving it a slant from the GTA or the Greater Toronto area. So just for all those, full disclosure. So starting with pre-manufacturing, so 3D structural systems. This is the project that I mentioned in the beginning, which was Box Park. This was a project where it was really about reusing existing shipping containers. This was a site where nothing existed yet, and the idea was to try to move this ahead, bring some economics to this neighborhood. So it was sort of a temporary piece that has remained anything but temporary. The people really love it. And then from here, we've sort of done a deeper dive to look at who else is doing stuff. So there's been some smaller projects that have happened in Ontario, but really you've got this one in New York. You've got ones that have happened in Calgary, all with different partners. On the left-hand side, you've got that City of Toronto project that happened a couple of years ago, which was a low-rise project, and it's just a way of sort of a pilot project of advancing housing quickly. Then you've got Faro International in this space, you've got Stack Modular, and you've got Beck, amongst others. These ones I find quite fascinating. So these are the ones that have been finished in London recently. So 50-story, 817 units, plus a 35-story, 120 affordable units. And these are the tallest volumetric in Europe. And 73% of the floor plate was built in 32% of the schedule. So this is a 28-month schedule, which is really quite remarkable. And so you can see Vision is really the ones that carry this through. And here you see Vision Tide again, partnering with Greystar at 38 and a 44-story building, 1,500 units, 42% of the schedule savings. So a 26-month schedule. So you can see that they're getting faster. I went from the most recent to the ones that came afterwards. And for me as an architect, what I love about these is they don't look like they're modular. You look at them and they've got an architectural finish to them, which makes me say we're developing and we're getting further in this way. And here's another 27-story, 18-month schedule for this one, which is truly remarkable. So this is kind of the holy grail. But what we're really seeing is that a lot of what's happening is kind of in this hybrid side more than the volumetric. So volumetric is one way, but we're seeing hybrid as another piece that's coming on a little bit more quickly. So 2D primary structural systems. So this is the category 2. So some examples of things that we've done in this space is this MV1. These are the structural wall panels. These are prefabricated structural walls and floors. And the demising walls. And so we've done a couple of these with Home Plus Technologies. Hot Condos was the first that we did. It was the first one that they rolled out of their factory back when they were Brockport. And we did a lot of learning just about tolerances and how pieces fit together. And then, of course, other companies in the space like Assembly and Panelized. Into category 3, pre-manufacturing components, so non-systematized structural systems. So this is things like precast hollow core slab. And we're doing this one here on Lakeshore. This is all about the slabs and cold form steel for the walls. And then moving into Valhalla Village. So this one we're using the MPS system, so the modular precast system. We're also using their wall system, which is a category 5. So I'm going to go a little deeper on this project when we get into the next part of the presentation. 80 Atlantic here in category 3. So this is about mass timber. So we used glulam columns and beams and NLT floor panels. We partnered with Timmerman in Nordique. This was for Hallmark here in Toronto. And this was that one that was the first mass timber office building to be built here in a century. And so construction schedules really could take advantage of these fabrication. It was all about just-in-time delivery, and I got to see it live because this was one of my projects. It was very exciting to see, kind of one of the quietest sites I've ever been on, one of the ones where it was extremely clean and things happened really efficiently and effectively. And it was really all about, it probably could have gone faster, depending, it was all about when things arrived on site and making those logistics tie together. And so this was the first one we were doing, and the first one that a lot of the trades were doing. And of course, one of the aesthetic advantages, again, speaking as an architect, is the ability to expose that timber. And so really here in Toronto, this has really become kind of a hive of mass timber activity. So over the past few years, we've seen an explosion of mass timber proposals. A lot of these here are on the commercial side. And the question we were asking was, where is the residential? And so there were a few low-rise mass timber projects initially, but since the Ontario Building Code introduced encapsulated mass timber provisions, we've seen a growing number of residential projects being announced. And these appear at sort of a variety of different scales and across a range of different residential types. So I'm going to go a little deeper into 2453 Bloor Street West. This is a mass timber building that we're looking at, where it's the primary structural system, glulam columns and beams. And so it's really all about understanding kind of the differences between mass timber and what we've been traditionally used to working at for this scale of building here in Toronto. So I'm going to talk a little bit about that. So of course, the first piece was really understanding the supply chain. Where are things coming from? Who has things available? And how do we deal with that? And how do we engage with this part of the industry? And given our experience on 80 Atlantic, we had a little bit of a sneak preview. So looking at what kind of systems exist, post and beam, timber slab band, timber concrete composite, asymmetrical flange beams, flat plate CLT. The focus really for multi-unit residential that we found was really on these two, post and beam and flat plates. So we decided we needed to figure out kind of how these applied and how you took this into the residential side. So looking at things like structural alignment, which of course is always key, yet something we don't tend to always do here in the Toronto market. And from these, you can see that this is kind of a super, it looks great on the inside in terms of finishes. And then you've got the flat plate CLT, which means you've got no running beams that you have to get across with your mechanical systems. So this system requires each CLT panel to be supported by columns at regular intervals along the panel length. So looking at the maximum structural efficiency, these columns really need to be placed between 3 and 3.5 meters apart. And ideally, the spacing is determined by the supplier's minimal or maximum panel dimension, because the larger the panel, the more efficient. And just a couple of examples here with Brock Commons. So for us, we took our sort of typical suite module and said, how does this actually apply? So taking your parking module, knowing you have to run these on top of each other, what should that grid size be? And then working with a local example, so looking at element 5 in St. Thomas, Ontario, we're looking at an overall panel length of 16 meters and a maximum width of 3.1 meters. And so then looking at how each of these would ideally be spaced over the panel length to work with the room layouts. So this naturally begins to define our typical bedroom, living spaces, and our resulting suite widths and suite areas. And then zooming out again, this is exactly the approach that we took on this development on Bloor Street, where we began preparing, starting by laying out those panels, layering on the grid spacing for a flat plate CLT system, and then selecting that column spacing as we talked about. Then defining where those panels, where the center of the floor plate is the zone for all of the vertical circulation services, leaving those outer panels clear and available for the suites. Given that this is kind of an intermediate rise building here on the avenues, we're required to do some stepping back. And so we knew we had to have an awareness of that. If we just followed the pure zoning, those step backs would be a little bit more arbitrary, but knowing here that we're working with the CLT, having to step back at more regular points. Adding in that corridor, getting to the point where you've got a typical floor plan based on a mass timber structure. So having to start this process right at the very beginning of the design. And then when to where the level of the building maintains this consistent structural logic, really defined by the ideal proportions of the CLT. So it resulted in a pretty standard looking building, but underneath it's really an efficient timber structure with the potential to deliver a building that's faster to construct and significantly lower carbon, especially when compared to what we would normally be building the scale of building out, which would be cast and paste concrete. To build at this height, you have to encapsulate mass timber, or you have to deal with, in order to have no encapsulation, you need to leave a big enough char depth, and then those panels start to get quite thick. And you can see those dollar signs there. So really trying to minimize those panel thicknesses to bring in some potential savings. And so across this building, there was about a 30% reduction in wood volume to get to this smaller size, which was great. Again, these various depths, no matter what depth you do, you really do have to think about it in terms of what it is you're doing and where you're placing it on the site. So going back to the Toronto mid-rise guidelines, this is our prototypical mid-rise. Looking at that, and these angular planes, they're really designed to work with a concrete building. So when you start to introduce things like a CLT plate, where instead of your 200 mils thick, you're adding a thickness to that for the CLT plus the buildup to the encapsulation, you start to stick out of that zoning. And when you move into a post and beam, that's even thicker. So this difference in height is one of the biggest reasons why this Jane and Bloor project chose that flat plate CLT. The difference in the floor height requirements was really the least significant compared to the baseline zoning assumption. So again, back to why thinking about kind of a modern methods of construction in the earliest days, when we're doing rezoning, we're years away from being able to realize the project. But if we're not doing this thinking early, we miss out on these opportunities. Moving into category 4, we don't have really any experience in this sort of additive manufacturing, but we're starting to see these companies coming out, which are really super interesting, really working in the lower rise housing sector around 3D printing. I'm excited to see what they do on the larger side as this develops. And then into category 5, where we're talking about pre-manufacturing, so these non-structural assemblies. And this is where we've started to see a lot of uptake, especially on the high-rise side. So we're just finishing up the CG Tower. We've occupied the bottom half of this tower. It's a 60-story tower in Vaughan, and we use these precast panels with the windows pre-installed, and I'll talk a little bit deeper about this one. So this is where it's located at Highway 7 and Jane Street. You can see it there outlined in red, adjacent to Edgeley Pond and Edgeley Park. This is what the rendering looks like. And this is what it looks like finished and in context. You can see it looks quite a bit different from the towers that are around it. You can see the sections here. So you've got it sort of stepping back in one dimension and then sort of flat plate on the other. And then these are the elevations. So you can see we've done something extremely regular with the patterning of the facade. We worked very carefully to make sure that we only had a handful of window sizes to work with these and panel sizes. Here you can see the mock-up. So the mock-up was actually built. So our partners in this, it was the Cortel Group, who was the client, sort of developer, as well as the contractor. And this was Global Precast and AWD, who did the windows. And this was built in Global's yard. So they installed the windows, and then we went in to take a look for the mock-up. And then the air and water testing was also done there in the yard. And so the great thing here was you could figure out all the issues and decide on a better way of doing it before you got to the site. And then here you can see transportation and installation. So they were brought in on flatbed trucks. You can hold about 4 panels per flatbed, and you can see them being hoisted up in the air. So here they said that they could do about a floor and a half a day, but given that they had to share the crane time, they would split this over sort of 2 afternoons. As we were wrapping up this project, what we did is we held a post-mortem with the client. And I do think that when you're doing new things, one of the most important things is sitting down and having a conversation with the client afterwards about how it went. And they found that the system far outweighed the challenges, and it was all about that coordination of the of the crane time. And then the coordination of the manufacturing timing and installation logistics between the window manufacturers and the panels. So if one got ahead of the others, you'd end up with a buildup of windows or a buildup of panels. And it was great because what they ended up doing is they ended up building a tent in the precast yards. So the window installers came to Global's yard and did the installation right there. They were warm, they weren't up high, so it was definitely less dangerous, and they could bring things up to a higher level of quality control. And then the other benefit that came out of this is normally you'd be hoisting these windows up along the hoistway, and so they found less hoistway congestion for the rest of the trade. And then also a 30 to 40% savings on winter heat. Originally, they'd been worried about damage to the panels or the windows in transportation, but they confirmed that nothing happened, and they believe that there'll be cost savings the next time they do this. And the bonus here is that after they did this, they said, okay, now what's next? Now we're working with them to develop a panel that has a balcony integrated as well. And so the key is continuous learning when you're doing things like this. And so this was sort of how they described the differences between on the left being our precast with the windows pre-installed, and on the right doing your precast pieces and then installing the windows after. And they found there was about an 8 to 10 week schedule savings between these two systems, which I thought was really interesting. Another thing that we did to speed up construction was we halfway up, we put a mechanical penthouse and we separated those elevators so that they went about halfway up the tower, and we were able to get occupancy of the lower half before the upper half. And you've got the design on the left and the reality on the right, which I find interesting because I feel like the one on the right almost looks like a model, but that is actually a drone photograph. The next project is Valhalla Village Tower D. So this is the one that I showed you previously where we did the MPS, the structural system, and we also did the wall system. So here's the two buildings here. On the left, you've got a building, Tower A, which was done with standard traditional construction, and on the right, you've got the modular precast. So the building is 11 stories. This is what it looks like. So here's our typical structural bay. You've got your vertical solid walls on the far left. You've got those pre-stressed interior beams and then columns with corbels to receive those beams, and then a hollow core slab. And those slabs are pre-stressed as well as the beams. And what that means is those slabs actually have quite a span, more than you would normally see in cast in place. And here you can see the typical wall panel. So you need a bit of an edge around the whole thing so that it has structural integrity as it's being transported and lifted to the site. So you end up with a punched window approach, which also works for sustainability. And here you can see a typical floor plan. So you can see just three columns in the north-south direction, which is just great. And then you've got your beams running in the other direction. So it really kind of regularized things. And this project was designed not in this way originally, and then this was actually a value engineering exercise, which was kind of interesting. And here you can see a typical suite layout. What you've got in the blue is you've got a bulkhead around the outside edge, and this is that edge beam. And so it's just slightly deeper than what we would normally have in typical construction. But other than that, it's pretty much column free. And then your here in Toronto, we do tend to love our shear walls. So normally between suites, you'd have shear walls running between the suites, but instead these are done with a steel stud gypsum board buildup. And then here you can see that section with that lower beam around the outside edge. And then moving to site, we got to see the mock-up, to go and take a look, again, built up in the yard. This is at MPS's yard. And so they did both the wall system and the structural system. So now what you've got two pieces or two modern methods of construction happening in parallel. And you've got one manufacturer that's doing both of those things with the windows coming from state and being installed on site here. And then I loved this contrast because we've got building A on the left and we've got building B on the right. So on the left, you've got traditional construction, and on the right, you've got this modular precast. So on the left, they estimated about 50 workers, and there were about 15 on the site on the right. So a lot fewer people. So more of the work is happening within the factory, and definitely a little bit less chaos happening on the site. On the left, so you've got your reshoring. On the right, they're working immediately above this, and it's nice and clear, no reshoring. And then on the left, again, contrasting the two. Here you can see the structural walls coming to site, and then the two-story columns, and then starting to lift those panels up on site. And so you can see on the underside of those structural walls, you've got these holes, and those are there. Those are kind of cast into the precast, and they slide over this rebar that you see on the left-hand side. And then when they crane it in, they're sliding that down over the rebar. And you can see that on the left here, they throw in some grout underneath. And then those holes are filled by hand on site. So those tubes kind of slide over the vertical splicers, and they're later grouted with a high strength grout. Sorry. And then here you can see some of the details. So the windows are all caulked and put in place before they come here, but then there's a lot of sealing and fire stopping that needs to happen between those structural panels. So you get a different mix of workers where you might have form workers and steel workers on the traditional site. Here you've got people doing sealing and caulking and sort of putting things into place. Again, the nice clear view, and then looking out across to the site adjacent that has all the reshoring. We did another comparative diagram. So on the left, you've got that precast concrete structure going in with the walls. And so let's say it was a 20-story structure, comparing that to building a 20-story structure using cast in place, and then a standard precasts and windows being installed on sites. We found that there was about an 18-week schedule savings. And so we're working with Reliance Construction on this, and they're going to give us the summary at the end of the day once they're done. But for now, this is our estimate based on what we're seeing. So they think they can get to a turnaround of one floor fully installed with the envelope in 2 weeks. And here you can see the design drawing on the left and the reality on the right. And then a few other examples. So going from precast, which is pretty common here in Toronto, moving into these other products that are coming to market. So things like these clip-on balconies. And then moving from that, what you see on the bottom is these sort of local precast manufacturers combining with things like these balcony manufacturers. So Sapphire Balconies working with the precasters to come up with ways of making those systems be able to fit in. Because at this point, the connection between the precast and that balcony system, there wasn't a good way to connect it. And so they're kind of resolving those issues. And now the next thing that we're going to see is really these high performance wall systems. And so we're starting to see this with Unity Wall, putting this is a U of T academic building, hoping to eventually see this on the residential side. But at this point, it's sort of not in the right price point. But I think as we move into these higher levels of sustainability performance, where we're required to meet near passive house levels, so the Toronto Green Standard here is our green development standard. And as those levels of performance continue to rise, I think we're going to see more of these precasts or these pre-assembled wall systems, high performance wall systems coming in. And then, of course, we've got the modular ponds. I understand one of these here is a factory in Moncton. And so right now we're only seeing this happen we're not really seeing this happen on the residential side, still more of the institutional commercial. Part of that, I think, has to do with sort of the quality of the concrete pouring that happens on the residential side, which doesn't seem to work to as high tolerances as the commercial side. So perhaps that'll shift now that we're seeing more of this precast structural system happening. So let's look at kind of what's next. So what we're thinking about here at BDP Quadrangle is this sort of power of concurrent engineering, which is really a systematic approach that thinks about this more like product design and how can we shorten up these systems, understand what's happening at the very beginning of the brief and with the zoning, and bring these conversations to the earlier part of the design stage, because we can't be thinking about these when we're going out for procurement. We need to bring this conversation to the front end, which can be a very, very long timeline. And then the other thing that we're thinking a lot about is unlocking continuous improvement. So this has been another piece, so like that example of the CG Tower project, where it was really all about making things better from one project to another, especially where we're working with a client over multiple projects. It just makes sense. Let's learn from what we did, let's make it better next time, and let's try one new thing on each project. This may be a little bit small to see, but this is our diagram. So we've been trying to put something together with Brandon and his team and with the National Research Council to do a research piece where we're looking at sort of packaging up the work that we've done, doing postmortems on those and rolling out a series of case studies. So you've seen sort of the earliest of this. This is the first time I've tried to sort of package things up. And then, kind of sharing those and then looking at systems, what is actually out there and available. And you saw bits of pieces in this presentation, mapping those things, doing factory visits, doing some deep learning, and then rolling out rules of thumb for these various systems, looking at the overlaps. Because what we really want to do is simplify the thinking around this and bring that into our front end delivery. And then, of course, doing this sort of market overview, talking to various people, having conversations and bringing those insights, and then using those three things to take it out to working with our clients and partnering with them on projects, whether it's on the volumetric side or whether it's on this hybrid construction side. And with that, I will stop there.
Great. Thank you, Michelle. There's a lot of information in a short amount of time. I don't know. Sorry, I want to make sure I can see you. There we go. Yeah, so I have some questions, and I see one question come in as well. I'll remind the folks to submit your questions via the Q&A there. I'll start maybe with Brian's question. And I think Brian will appreciate a lot of the case studies. He works with the CPCI. And considering how much precast was in the slides, he might have appreciated that. But he was just curious, is there any statistical or factual data showing that the mass wood structures can take the same loads after a fire? And he just said the UK does not support the wood industry's loading claims. I don't know if you're familiar with anything that you've seen.
Yeah, that's kind of like more to the structural side. So, I mean, I'm going to give more of a basic response, which is really that it's all about those char layers and, either using the char layers or using that encapsulation. But I know that the UK has a very different approach to this. I think given the Grenfell fire, I know that they're very reticent, especially to something that's combustible. We are in the UK working on a mass timber. We're working on a zero carbon lab there, and so we do have structural engineers that we're working with there that are actually part of BDP because we're an integrated design firm over there. And they're looking at, rather than sort of purely mass timber, they're looking at mass timber like a hybrid timber.
Yeah.
And so they're working through the details of that over there. And that's kind of the best answer I can give to that, I'm afraid, Brandon.
Yeah, no, that's great. I do know in Austria there's some precast mass timber hybrid systems. I'm not sure. Maybe that's what your colleagues in the UK are looking at as well.
Yeah.
I can't recall the name of the company off the top of my head, but I understood that they would kind of send the CLT to the precast factory where that would then be cast on top of it, almost use like form, like the mass timber was almost used like a formwork that would stay in place, and then you would see visually the mass timber, but then you'd receive a lot of the sound benefits and other benefits of concrete. So I would need to dig into it more to know why, like what their benefit is of doing it, because I'm sure there's more to it than
It's sound and vibration. It's multiple things because one of the problems you have with just timber is you've got the sort of the impact and the vibration, and so the acoustic transfer. So that was one of the issues. Even on 80 Atlantic, we used a kind of a 3-inch topping coat on top of the mass timber. So you've got the NLT panels, then an acoustic layer, and then you've got the concrete on top. But for us, it wasn't a composite slab. What they're doing for the lab, because of course those are much higher performance, is that's actually it's a composite slab. So you've got kind of metal that ties the two together. I mean, what we found in a lot of mass timber buildings is that they're rarely fully mass timber. There's often some concrete and there's often some steel in them to really make them work.
100%.
And it's interesting because when we were working on 80 Atlantic, we were feeling very purist about it at the beginning until we realized that you can only get of course you can only get a material to do what it does. You can't try to get it to perform like concrete because it just doesn't. right?
Yeah.
So you need to work with that. And that piece about taking what is a residential plate, what is a panel look like, and putting those two things together. I mean, that's the exercise. That's the design exercise. And yeah, in
Yeah.
terms of the loading, be more interested with that.
Yeah. Okay, we're starting to see quite a few questions come in, so I'll go through them. I'll put mine to the side for now. So, next one is just thank you for the presentation. Curious around, is there any non-combustible volumetric modular projects present? And the person says that they know in the UK Vision Modulars does this, but wondering if you're familiar with any of the volumetric modular ones.
Of the actual companies that do it, so things like Stack Modular or UNB
Yeah,
or
yeah,
Beck. I mean, there's a
I
few in
think so.
Ontario now, or Faro.
Yeah,
Yeah, and they tend to be steel systems. Yeah, so they tend to be steel is what we're seeing. And then some of them also have the option of doing like the combustible, but you asked about non-combustible. So yeah,
yeah,
those would be four of the companies. Then it'd be Polsum, I think, is the other one.
yeah, yeah. They're in Europe or local, or maybe I'm
I
getting
think they're
Polcom.
a combination, actually. I think there was one of the companies that has stuff in Poland and stuff in Ontario, and like they were in multiple places. And I think one of the challenges for the volumetric companies, I don't want to speak for them, but from what I've read, is keeping the pipeline of projects coming. And that has been the real challenge. So I mean, I'm dying to have a conversation with Tide, Provision Tide, about how they're doing it.
Mm,
Because I think that seems to be the ticket, is you have to have things in the pipeline. And I think with multi-unit residential, one of the challenges is, unless you're doing something like affordable housing or housing from the government that has a steady stream of, or a housing program that's being rolled out, it's very, very difficult, because especially what we're seeing in the GTA is things get really hung up in the approvals process, and they get stuck there for a long time. And you can imagine, if you've got this factory that's there producing, how much does it cost to keep that open every single day? And what you need is to be able to stoke the pipeline, which is, I think, why you've got these companies that are supplying to more than one place, or that are building elsewhere and bringing them here.
100%. Yeah, and I mean, I'm not sure if it's this way with the company in the UK, but a lot of the ones that are vertically integrated and act as the developer and GC and own
Yeah.
their own factory are seem to be the most successful. I even know, like, even with Sweden's with the less demand or to build housing right now. I think there's demand, but there's less of it getting built. Some of the Swedish manufacturers who are known internationally as leaders are looking elsewhere. And I heard of a partnership that they have with a Canadian company recently. So just going on here, the next one is our company is close to finishing R&D on an aluminum passive window wall for mid to high rise and commercial projects. We at Triumph Inc. would love to start a discussion with you. We're in Toronto. Would like to contact you. Okay, that's just
Okay. Okay.
yeah.
My
So
contact details are in the thing if you want to reach
yeah,
out.
yeah. Sorry, I thought that it ended with a question. I should have scrolled down a bit. So what are your thoughts on open source product systems like the WikiHouse? Do you think open source can help with rapid innovation?
I'm afraid I don't know much about
WikiHouse,
that.
yeah.
Do you know stuff about that, like
I
Brandon,
personally
or
don't. No,
no?
I personally don't. But I mean, from an open source side, even the project we're doing now, I think we're talking about sharing the knowledge and insights broadly with the industry. And I don't know if I think there's more collaboration and making and being more open is will hopefully stimulate innovation. But at the same time, organizations like BDP Quadrangle have put a lot of time into the systems and designs and things they do. So some of that is your own IP, and I can appreciate the hesitancy to potentially share.
Yeah, it's a tricky
Yeah,
one, because I agree with you that, I mean, open source is really the way to go. We know we sort of marked out those multiple crises happening at once, whether it's housing or climate or, well, financial. There's a lot of instability. And I actually think we need to build a lot of housing very quickly, and we need to do it low carbon. So we need to upskill very, very quickly. So I think open source is really the way to go. The question is, how do you keep that information accurate and real, and so that it's something you can trust? Because all you have to do is use it once, find it's wrong, and then it's problematic. So I don't think anything really replaces a conversation at the end of the day, but I think tools that are open source that are reliable, and that's, I think, what it's all about. Is like, if the tool gets you to sort of 80%, maybe that's good enough, but you can't rely on it for the whole thing. So that gets you from A to B in a short period of time, and then you need to go to the source of where those products are coming from. Like, even working on the mass timber side, we've worked with various structural engineers that were coming over from Europe, and they knew the supply chain in depth,
Mm-hmm.
and they knew exactly who had what size, because it's not like a glulam column is different depending who it's coming from. And that can be very challenging, because we're used to, with cast in place concrete, you can make it whatever size you want. And if you say
Yeah.
it's 600, then it's 600, and everyone does it 600. But with mass timber, the sizes vary. So how do you design that into your design? And then you have to have that understanding. But if you decide you want a 445 millimeter column and only one person can supply that, now the costing of your project is totally different. So you have to design with that flexibility. So something like a wiki would be helpful to understand all of the range of things that are available, and what companies are available. And then once you have that information, you kind of have something for that concept design, maybe schematic design, and then you start talking to the manufacturers to make sure that you've got that right. So I do think it's a combination. I think there's a lot of room for open source sharing and things like wikis.
Yeah, yeah, for sure. And I think the that whole concept of, like, I know for some of the projects locally, just engaging those manufacturers early in the process is key to ensure that you don't, pigeonhole yourself and then only one supplier can supply what you're looking for, or sometimes even no one will, because they'd have to change up their factory or whatever it might be. I do have a comment from someone at Faro. I know Emmanuel. Thanks for attending, Emmanuel. He just wanted to clarify Faro uses steel and wood, or a hybrid of both in the modules. So just wanted to clarify that.
Yeah.
Try to get through a few more here. So one is, how are product configurators being integrated into construction projects to enhance mass customization? So I think this goes back to what we are
Well,
talking about.
we've seen a few companies doing it. So again, there's different delivery models. I think this is part of what's, like, I'm talking to you about it, kind of coming from the consulting side, trying to figure out the role of the architect in all of this, right? And so we're used to working a certain way. And so things like configure, they're bringing those things. So there are companies that are doing, as you said, they're doing that full service delivery from developer all the way up to managing those buildings at the end of the day. And they're putting their pieces together, and so they're designing that whole process, and it's all very technology driven. Where it can get very challenging is where you're working with multiple consultants in some ways in a more traditional setup, where you're not actually all on the same platform. So it does take these kind of collaborations to make those sorts of things work. And I think that's why you end up seeing a lot of sort of pilot projects, or you try it out on a small project. I don't know if that sort of satisfies it, but I do think that there's going to be room for different methods to come in, and technology is a huge piece of the puzzle, and some are going to come at it from different ways. So we're sort of coming at it from the design side, working in an industry that already exists, that's sort of adapting slowly while also trying to upskill on some of those things that we think are moving more quickly. So I do think you've got many things happening at once,
Mhm.
and it's a matter of selecting which ones you put your time and energy into.
Yeah, yeah, for sure. Um, yeah, so I'm just looking. So we have one from June, our friend at NRC. So he just says, thanks, Michelle, for the presentation. Does the schedule savings presented on the various case studies in the presentation include the overall project delivery process, or was it based mainly on the on-site construction schedule? If
Which is
latter, go ahead.
sorry. No, go ahead.
was going to say, if the latter, I wonder if it would be possible to capture the pre-construction information as well on these projects to see which systems are easier to move through the regulatory approvals process for the different types of buildings or by different regions, municipalities, essentially like setting a benchmark for different systems by geography potentially. Yeah.
Yeah, I think that's a great suggestion, June. And so just to answer the initial question, it's all based on what's happening on the site. It's
Yeah.
all based on the construction timeline. It has nothing to do with what happened before. And the thing that I'll layer onto that is that the the approvals process far outweighs any other complications for those first 2 years of working on a project. It's there's so much mixed up in that. I don't think it really changes the approvals process. Even working on 80 Atlantic, I mean, we were the first to be building a mass timber building here out of under the new code, the 2012 code. And what we did is we went and we had those conversations with the authorities having jurisdiction. We went in and they said, okay, red carpet delivery, this is how we're going to move forward with it. But it was challenging still. I mean, that very first meeting we went with the city, they brought every single plans examiner. Okay, we're all going to learn from this. So I think I like the idea of benchmarking. I think it's going to be something that we get better at over time. And I think we have to decide what those metrics are that we want to measure and then consistently measure them across each of these projects. So for now, we're starting with the construction phase because even a project like Valhalla was designed with traditional construction methods initially, and then we
Okay.
switched. And so that was
Ah,
kind of an interesting one because that actually happened rather late in the game.
what was the
Ideally,
rationale for the switch?
actually was cost savings. It was
Oh,
multiple things. So it was the financing model because it became an affordable housing unit, and they went for the grant. And so it's a zero carbon building. They went with the zero carbon standard, the CGBC zero carbon standard, and affordable housing. And so that combination, they managed to get their financing loan at a reduced rate. And
okay.
that plus going with the MPS system brought the cost down. It was significant. It was a few $1 million actually that it brought the cost down. So because the other
Oh,
thing that happens in Toronto, we're very used to being able to use cast in place concrete and to be able to, move our structure around as if transfers don't matter. And with
yeah.
this, it applies a certain rigor that you have to hold to because otherwise the system doesn't work.
Yeah.
Uh,
Yeah. 100%. Yeah, quite a few of the developers that I'm familiar with in Toronto, they're still using cast in place. I think it's still quite common, but
oh, it's yeah.
um yeah, yeah. So I just want to get to one last question before we wrap up, and there's a thanks from John at Stack Modular for mentioning the organization, and just a comment from Brian around the how they at CPCI found minimal advantages of like full volumetric modular precast versus panelized precast, I think. So just a comment there. But Helia, sorry if I mispronounced that. She just says, thank you for such an amazing presentation. It's funny because the Vaughan project is right in front of our building. I've seen how the panels were delivered. However, she's wondering, were those panels completely CLT?
Not CLT, they were cast in place. They were concrete. You're talking about the
Yeah.
tower in Vaughan, right? Yeah, those are
Yeah.
precast panels with at Global Precast is just a few blocks away from there. Actually, it's very close. So precast concrete with the windows installed.
Yeah. Yeah. Okay. Yeah. No, that sounds good. And you're seeing more of those precasters looking at bringing more activities into the factory. I imagine, whether it's window installers, or are any of them talking about mechanical, electrical, or plumbing runs
Well,
in the
the
factory?
one we did for Valhalla, the mechanical was already embedded in the window. So the exhaust was already there, which was great because
Okay.
it meant that the mechanical was just coming and plugging into it. And so I don't
Nice.
know whether you mean like mechanical systems sort of separately. Is that what you're asking, or is it
Yeah,
or
well,
integrated with
we've
the
talked
wall?
to a few of them that are looking at integrating or even running conduits. So you have kind of plug and play connections at the end of panels, and it's stuff we've looked into, even the structural connections, a bolted connection versus welded, and things like
Yeah.
that. So Yeah,
I mean,
but
yeah, I think I'm seeing some stuff, but I'm seeing early days stuff. I haven't
yeah,
seen, yeah, and in the residential space, I think it might still be a while. I think the other challenge, I think, also with private sector residential is that it also has to do with the sales cycle, right? Like,
yeah,
and if things aren't selling, you redesign the units. And so that does not suit this kind of construction. So the idea is to find a commitment to a design that's going to stay that way until the end. And how do you do that?
yeah, yeah.
So
No, yeah, I could see that as well. And then that's we've had conversations with some of the developers to understand their rationale and how their financing and businesses and insurance and all that works. And I think understanding that perspective is important to actually making a difference and leveraging more offsite technology or MMC. So I'm just going to wrap up. I know we're at time here, so thank you again, Michelle, for your presentation. We're back in March, the third Thursday of March. I don't have that date off the top of my head. It might be March 20th, actually. And we have OD Craig from Intelligent City. So Intelligent City is based in Vancouver, BC, and OD's going to be presenting on what they're doing. I understand they are undertaking their second project, so they're kind of a startup, Canadian-based startup, and they're undertaking their second project, a 9-story building in the GTA, where they've partnered with a European company as well as a developer local in the GTA. So, yeah, thanks again, Michelle, for your time, and I hope to see everyone in March. And just a reminder, all this is recorded, so we'll have it on our website. We'll have a blog out, and if you have any more questions or want to reach out to Michelle, she's active on LinkedIn, and you can reach out and get her email from me, or if you caught it there at her last slide, well, you can reach out to her directly. So thanks again. Have a great rest of your day.
Brendan.
Okay, take care. See ya.